everyone, this video is about building a machine learning system in Python that can be trained and used for air quality forecasting. Machine learning is all about data, and we will be feeding a dataset to the machine learning model, and this model will try to learn from this data, and based on this learning it can make future prediction. So in this video, let's try to understand how we can implement this for air quality forecasting in Python. Okay, so let's get started. So before going into the coding part in Python, let's try to understand what are all the different steps that we have to follow and what is the workflow for this particular use case. So the first part in any machine learning project or use case is data collection. So in this data collection, we will try to find which is the best suited data set for our use case, for our problem statement, and so on. So in this case, we will be using the air quality data set in UCI ML repository. So I'll show you how you can get this data set. So that will be the first part. So once we get this data, so the next part will be understanding the data that we have. So we will try to understand how many data points we have, so how many rows are there and how many columns are there in a data set. Okay, so and we will try to find what are all the different data types in each column, and whether there are any missing values in the column and so on. So we will try to work all these things. So this is just some basic analysis of the data that we have, and the next part will be data processing. So you can also call this as data pre-processing. So once we have this data, we cannot feed this raw data to our machine learning model. So we have to process this data so that it is compatible to go with the ML model that we have. So we have to process the data according to our model that we have. Okay, so this part is a data processing, and once we process this data, we will feed this data to our machine learning model. In this case, we will be using the FB Prophet model. So this particular model is developed by Facebook, and so this is one of the important forecasting model that we have. So forecasting models are those where if you give a time series data, it can give you future predictions and forecasting. So for example, you can build weather forecasting models or stock price forecasting models and so on. So this is the idea of FB Prophet model, and we will be training this particular model. So once you train this FB Prophet model, it can be used in order to make future predictions. Okay, so we can get some trend on where these values are going. So this is the overall thing that we are going to do. So first we have to collect the data, and then we have to do some basic analysis, and we have to understand the data, and later we will process this data. So once the processing is done, then we can feed this data to our FB Prophet model and predict the future trends and so on. Okay, so now let's go to Google Colab in order to do the Python programming. Okay, so I'll open my Google Chrome. So if you haven't used this Google Colab, I'll just show you how you can access this. So Google Colab is developed by Google. So here you can run any Python commands and Python programs and so on. So most of you might already know this. If not, so I'll show you how you can access this. So just go to Google Chrome, search Google Colab. So you will see this collab.research.google.com. So this is like created especially for data science and machine learning applications, and all the necessary Python libraries will already be pre-installed. Okay, so that is the advantage of it. You don't have to install any software in your system, or you don't have to install any libraries and so on. So that is the advantage of using Google Colab. So click this Google Colab, and here you can see this option called as new notebook. So this will create a Python notebook, and this particular notebook will be saved in your Google Drive. Okay, so this is just like the Jupyter notebooks that we have in Anaconda. So this is how you can create your notebook, and here you will see this connect option. Okay, so once you connect this, so your session, so this Google Colab session will be connected to Google's backend server, and on those particular servers our code will run. So this is the idea of Google Colab. So I already have this Colab file called as air quality forecasting using ML. So you can just rename the file here, and you have to click this connect. Okay, so I'll just remove this cell and I'll go to this one. So here you can see this option called as reconnect here, right? So I'll give this a reconnect. So this will connect my system. So in this you can create text cells and code cells. So if you see here, there is an option called as code. So if you click this code, you will get a code cell where you can write Python programs and Python codes. Whereas if you click this text, you can write some description about the code that you are building. Okay, so here I have created a text cell, and I have written this as importing the dependencies. Okay, so here my system is now connected. You can see this green tick mark, and if you hover your mouse to here, you can see the amount of RAM that you have, which is like 12 GB of RAM and 107 GB of storage that you have. Like 12 GB RAM is a sufficient amount for our machine learning use cases. Okay, so I'm creating a text cell, naming this as importing the dependencies. Dependencies are nothing but the libraries and the functions that we are going to use. So first I'm importing the basic and important libraries that we have in Python, which is NumPy and Pandas. So I'm importing this NumPy in short form as NP, and I'm importing Pandas as PD. So the application of this NumPy is it is used to create and process several numpy arrays. Okay, so pandas is useful for creating data frames. So the data that we have will be in the form of a csv file. So you can see here, so this is the dataset file that we will be working on. I'll show you how you can get it, but let's try to understand this. So what is a csv file is all the values will be separated by a comma. Okay, so if you see here, this is how the data kind of looks like. So in this case, instead of comma we have semicolon, so we can come back to that later, but this is the data. So it's pretty hard to process the data when we have this in this particular format. So we will load this data from the csv file to pandas data frame. So data frames are nothing but structured tables that we have, and once you import that data to this data frame, it is easier for us to do the processing and do the analysis and so on. So that is the application of this pandas library. And I've created another text as data collection, and I have given the data set links. So just go to Google and search UCI air quality data set. So I hope like everyone knows about this UCI. If not, it's not an issue. So UCI is a famous data repository where it contains several machine learning data sets which we can download and practice on. So this is the data set that we will be working on. So air quality data set. So in order to download this dataset, you have to click this data folder where you will see this option called as air quality uci.zip. Okay, so if you click this particular file will be downloaded. So this file is a pretty small one, so it is like 1.5 MB of size and so on. Okay, so this is how the data set will look like. So this compressed file has two files. One is air quality uci, which is in the form of CSV format, and it is also in the form of Excel format. So let's take the CSV format. So I have extracted this particular file here, and I have also created a copy of this dataset file. So you can just extract it and create a copy if you want. I have also put this dataset in my desktop so that I can access this easily. Okay, so air quality usa.csv, and this is what we are going to use. Now let's try to understand what is present in this particular dataset. Okay, you can see, so this is the description of the data set that we have. So you can just go through this. So this contains the responses of a gas multi-sensor device deployed on the field in an Italian city. Hourly responses average are recorded along with gas concentration references over a certified analyzer. So they have multiple sensor in order to record certain values, and how this values is recorded is basically hourly basis. Okay, so hence we call this as time series data, where we don't have the data alone, but we have a particular time stamp to it. Okay, so this is called as time series data, multivariate in the sense we have multiple variables in this data set, and the number of instances is 9358, which means we totally have 9358 data points. Okay, so number of attributes is nothing but the number of columns that you have and so on, and associated task is regression is one task, and forecasting is another task. Let's discuss about this things in the later part of this video, but just go through this and try to understand what this data is all about. You can see what are all the different columns that you have here. So it is a short description of this. You can also see here attribute information. First you have the date. So the date is in the form of day, month and year. So this is very important for us. And we also have hourly data, so the timestamp data, which is in the form of hour, minute and seconds. Okay, and then we have truly averaged concentration of CO, so carbon monoxide concentration in milligram per cubic meter thing is there. So from this reference analysis, so this is nothing but all this data are collected from the sensors that they have used in this Italian city, which we have seen. And then you have this pt08.s1, so you can see this. So nominally CO targeted. So these are like the different pollutants that we have in air. Okay, so and then we have this non metallic hydrocarbon. So we know that hydrocarbon is another pollutant in air, and we have this nitrogen dioxide, nitrogen oxides and so on. So these values are there, and we also have this temperature in degrees Celsius, relative humidity percentage and absolute humidity. So these are all the 15 columns that we have. So you can see the value is 14, but this is like 15 columns because the numbering starts from 0, and also in Python the numbering starts from 0. So we totally have 15 columns. So this is the data set that we will be working on. So I hope that you have downloaded the data from here. So I have also given the link here. So this is the link of that particular site. Okay, so this is the link of this site. So if you want to download the CSV file directly, so instead of downloading the compressed file, if you want to download the CSV file directly, I have given the link in this collab file itself, and I'll also give the link for this collab file as well. So you can download it, go through it, and you can also do your own programming with this particular file as a reference. Okay, so So you can download the dataset from either this USA repository, or you can download this CSV file directly. Okay, now we have to upload this CSV file to our collab environment, and let's see how we can do that. So once you have connected your system, so you can see an option called as files. So this is where we are going to put all the folders and files that we will be working on. So here you will see this particular option, which is upload to session storage. You can click this, or you can just come here and you can just right click. Here you will see an option called as upload. So you can either use this upload, or you can click this particular icon, which will show your system files and so on. So we know that I have this CSV file, the R quality dataset, in my desktop. So I'll upload this to my session storage. So this is a very small file, so it won't take much time. Okay, whereas in most cases we will be working on dataset files that are like very huge, so it will be like 1 GB, 2 GB, or even 10 GB and so on. So this is a pretty small file, so it is about like 766 KB and so on. Okay, so now we have to load this data from the CSV file to the pandas data frame, and let's see how we can do that. So this part, so I'll just create a comment here. So in Python, if you want to write some comments about your code, you can use this hash symbol. So this part will be loading the data from CSV file to pandas data frame. Okay, so pandas data frame, and I'll name this data frame as air quality data. Okay, so you can give any names, but I'll just give this name as air quality data. So you can give df for data frame or anything you want. So air quality data is equal to, so here we are going to use the pandas function pd.readcsv. Okay, so read CSV stands for reading the CSV file. So pd is nothing but the pandas library that we have imported. Okay, and within this parenthesis we have to mention the path of the dataset file within this quotes. Okay, so give this files. So go to this files options, and you can say this R quality uca.csv. So you can see this three dots, which is nothing but my options. When I click this, I can see this copy path option. So I'll copy the path of this file, and let me put this. Okay, so this content is nothing but this location, this directory. Okay, so if you are working on Spider or PyCharm or other IDEs, you have to mention the location where you have stored this dataset file in your system. Okay, so this is the location where my air quality UCA data is saved. So I'll run this one. So this will create a data frame called as air quality data. Okay, so I haven't run this first cell, so that's why I'm getting this error. So import numpy as np pandas as pd. Now I can run this one. Okay, so this will create a data frame called as air quality, and now we have to check whether the data is loaded properly. Okay, so for this you can print the first 5 rows of the data frame. So printing the first 5 rows of the data frame, and for this you have to mention the data frame name, which is air quality data dot head. So yet parenthesis. So when you say this air quality data dot yet will basically print the first 5 rows in your data frame. So this is the data frame that we have, but we can see here the data is not structured properly. So it is not in the form of a proper structure. So that is an issue. So the reason for this is usually what does a CSV file means, like it is comma separated values, but as we have seen before, all the values in this case are separated by this semicolon, right? So it is separated by this particular thing, and we have to tell the pandas library that it is not separated by commas, it is separated by this particular symbol. So we have to tell that to our pandas data frame, and for that what we have to do is I'll copy this one. So I'll copy the same thing. So you just have to include another attribute here. So the attribute that I'm going to include is separation is equal to okay, so separation is equal to, so within this quotes I have to mention it as this column. Okay, so because the default one is it will consider this as comma, but it is not the case in our data set, so hence we are mentioning this. Okay, and the other important thing about this data set is if you see this particular column, so the decimals are so that decimal values, so instead of decimal values we have commas and semicolons, right? So we have to do that as well. So but okay, so let's come to that later. So I'll just run this one and see what is the data set file I'm getting. So I'm mentioning the separation is in the form of semicolon. So I'll copy this yet again, and let's try to print this. Okay, Okay, so now we can see here, before it was in an unstructured format, right? But now this data has been loaded properly to this data frame. So you can see, so first we have the date column, and then we have the time. So the timestamp is there. 18 means like the 18th hour. So it's like basically like 6 p.m. 19 is 7 p.m. and so on. So we have the date, and the date is like 10th of March. So third, we know that it is March 2004. And so how I am saying this is, so here they have given that the date is in the form of date, month, and year. So in some cases, the date will be in the form of year, month, and day, or it can be in the form of month, day, and year, and so on. So here it is in the form of this particular format. So we can understand what the date is, and we also have the time. And they have mentioned here is time is in the form of hour, minute, second, and so on. And then you have this COGT. COGT is nothing but this one. So true hourly average concentration of carbon monoxide and so on. So similarly, we have all these columns here. Okay. So this is the thing that we have. And if you see this column, so this is actually 2.6, but the value is represented as 2,6, right? So what happens here is, so instead of decimal point, all these values have commas. And for this column as well, so the C6 H5 column as well. And again, so if I go there, so it is also there in this T column and RH column, AH column. So in these columns, so instead of decimal point, these values are represented with commas, right? So we have to change this for this purpose. So when you are loading this data set file, you can mention decimal is equal to within the quotes you have to mention comma, because comma is given in the place of decimals, right? So when I run this one, again we will load this air quality UCI data to the data frame called as air quality. So this will create a new data frame, but while reading the CSV file, all the separations will be considered as semicolon instead of comma, and all the decimals will be considered as commas. Now let's try to run this one, and now let's print this yet again. Okay, so here, if you see, all the comma has been converted into decimal values, and for all the columns of previously T was in the form of 13,6, 13.3, and so on. So all of these columns have been converted to decimal points. Okay, so here I'll just mention as the text as all the values in the CSV file are separated by semicolon. Okay, by semicolon, and mm, few columns have comma in the place of decimal point. So in order to rectify this only, we are loading this data in the form of this with the attributes SCP. SCP means separation of decimal as comma. Now we get the data set properly, right? And if you see this, there are some unwanted columns. So unnamed 15, unnamed 16. So these are like kind of duplicate columns. So here, if you see this UGIML, so we have the columns until only like absolute humidity, which is represented as AH, which is my 14th index or my 15th column. Whereas in this case, if you see, you totally have so like 15 and 16. So there are like two unwanted columns are there, which contains only NaN values. NaN values means like missing values, are like NaN stands for not a number. So these are just missing values, null values. So we can just drop these two columns. So we can do that now. So this part will be uh, okay. So just a second, removing the last two columns from the data frame. Okay, so for this we have to mention the data frame name, which is air quality air underscore quality underscore data is equal to, again I'm mentioning log. So I'm going to locate few values. So what values I'm going to locate is semicolon, sorry, this colon, and this should be -2. Okay, okay, so this shouldn't be the format. So it's represented as mm, -2. Okay, so this is called as slicing the data frame. So if you have worked on Python, we would have came across this string slicing, where we kind of slice only the few letters and so on. So similarly, we are going to slice the data frame that we have, and this is like the format for it. So what we are basically doing here is, when I say this air quality data dot ilog and -2, this will remove the last two columns that is present in my data frame. Okay, so if I mention this as 1, the last column alone will be sliced, and if I mention this as minus of 5, the last 5 columns will be removed and so on. So that's the idea. Here the last 2 columns are the unwanted columns, so I'll mention this as minus of 2. So I'm slicing my data frame, and now again I'm going to print the first 5 rows, and I'm going to check whether this has been stored. So we are making this change to this air quality data. We are storing this to the data frame with the same name, which is air quality data, and you can print the first 5 rows. Now, if you see here, we don't have those unnamed 15 and unnamed 16 columns because we have removed them. We have, only up to this AH. Okay. So from date to AH are the columns that we have. So date to AH. And the next thing, like you can do is, so this is just basically to print the first 5 rows, right? So similarly, you can try to print the last 5 rows of the data frame. So I'll just copy this, and so we have seen that. So this is for last 5 rows. So for printing the first 5 rows we have to use the yet function, and for printing the last 5 rows we have to use the tail function. Okay, so I'll run this. Let's see what is the result we are getting. Okay, so all the values are NaN. That means like all the values are missing. So we have to understand what is this, or why we are getting this particular thing. If you go to this dataset description, you can see that there are like 9358 instances. That means like there are these many data points, or you can consider this as number of rows. So number of instances basically represents the number of rows that you have in the dataset, and number of attributes represent the total number of columns that you have. Okay, and if you see this one, I'll try to print the shape of this dataset as well. So here I'll print the dataset shape, which is like air quality data. Sorry. So air quality data dot shape. So shape will tell me how many rows and columns are there. So I have totally 9471 rows and 15 columns, but actually the data set contains only 9358 columns, and the remaining columns are just this null values. Okay, so if you open this particular data set in Excel file, so I have created a copy and I'm going to open this in Excel. So if you just scroll to the bottom, so 9356. Let's see until which part the data are present. Okay, so now you can see my last value or last data point is this one. Okay, so which is like the date is 0404/2005. So you can see, so 2005, and this is the timestamp. And after that, all the values are just this, semicolon. So these are just the null values or the empty values, right? So we have to remove all these things. So like these columns are represented as NaN in our data frame, so it's like nothing much complicated in it. So we have to remove all these columns, and that's the idea. So I'll just close this one, and now I'm going to, so we know that there are like 9358 instances, right? So the index will be, I'm going to print this last row. So I can say air quality data, mm, air quality data of 9356. Okay, so let's see. Okay, so there is some error that I'm getting. So okay, so we have to mention another square bracket. So I'm just printing the 9356th row from this data frame. Okay, so let's run this. Okay, so I'm missing. Okay, okay. So we have to mention another square bracket here. Invalid syntax. Oh, sorry, I'm just making this mistakes. Let's see whether it is working. Index are in the columns, so air quality data. So what am I missing here? Okay, sorry, so sorry, so it's my bad. So it should be air quality data dot loc. So we are again locating certain values. The values that we are locating is 9356. Okay, so this is my 9356 value, and now I'll just print the 9357 values and print this one. So if you see here, this value is kind of missing, right? So my last value will be 9356. So this is my last value. So in this case, the total number of instances given is 9358, but here you are getting this as 9356. The reason is, as I've told you, in Python the numbering starts from 0. So 9356 means 9357 values actually, and here you have this 9358, right? So that is nothing, but this will also be considered as one row. So that's the thing. So but this is my last row. So we know that, right? Because like you can also check this with this. Excel file. So I'll just open this with Excel and go to the last data point that I have. So the last data point is 4 and the value is 5028, right? So if you go to this Chrome, so 5028. So this is my last value. So I'll just close this Excel file. So what I'm going to do here is I'm going to take only the first 9356. So these data points alone. So all the remaining columns, sorry, all the remaining rows, all these null values will be removed from my data frame. Okay. So I'll just mention here that I'll create a text and put this as 9356 represents, this is just the numbering of the row. Okay, so 9356th row represents the last data point, or you can consider this as a row, last data point in the data frame, and remaining rows are just null values. So null values are nothing but empty values. Okay, so we can take these values alone, and again, as I've told you, as the indexing starts from 0, so the index of this 9356 is it's 9357. So if I we can say that index is 9356, but the actual number of row is uh, 9357. Okay, so I'll just put this as 9357 row. So what I'm trying to say here is, so we know that here it is mentioned as 0, 1, 2, 3, 4, 5, and so on, but the last index is 14, but actually there are like 15 columns, right? Because the numbering start from 0, so 14th means the 15th column. So index will be one number less in Python. So if index is 9357, that means there are totally 9357 rows. So if you compare this to it, the index is 14, but actually there are like 15 rows. So that's what we are trying to do here, and I'm going to take the first 9357 rows alone. Okay, so that's the reason I wanted to make sure that this is what we have. So here I'm going to take the first 9357 rows alone. Okay, so rows alone from the data frame. Okay, so for this I'll mention this air quality data. Air quality data is equal to, we are going to use the same yet function. So dot yet, when you don't mention any parenthesis, it if you don't mention any values inside this parenthesis, it will print the first 5 rows. Whereas if you mention some number, so I'll mention this as 9357. So what this will do is it will return me these many number of rows from this data frame. Let's try to print this one. Okay, now you can print the yet, or yeah, so I'll just print the yet as air quality data dot yet. Okay, so this is my first 5 rows. Now I'll print the last 5 rows. So we know that for this we have to use this tail function, right? So I'm using the set function. When I run this one, it will return the 9357 rows from the data frame, and that will be stored again in this data frame. You can also rename this, that's up to you. Okay, so I'm just keeping the same name so that we don't have any confusion and so on. Now previously when we run this tail, we have 9470 rows and all the values are missing, right? Now let's see whether this particular change has been implemented. So we know that 9356 is my last row. So you can see this value for a reference, which is like 5028. So now tail, so this is my last 5 rows. So what this means is basically all this null rows has been removed. Now you can also check the shape again. So let's see. So air quality data dot shape. So this is the actual length of the data, which is 9357 comma 15. Okay, so we have 9357 rows or 9357 data points and 15 columns are there. Okay, so this is one of the important things that we do while processing the data. So training the model and evaluating it and so on, so these processes doesn't take that much time. So a lot of the time in any data science project and machine learning project goes mainly to processing the data that we have. So you have to be very clear on these steps. So the next part is, let's try to understand the data somewhat better. So getting some info about the data set, getting some info about the data that we have. And here I'm going to use this air quality data dot info. Okay, so info, let's see. So what this basically tells you is whether there are any null values. So null values means missing values. Non-null values means values that are present, the values that are present there in the data frame. So we know that totally there are 9357 entries. When the value is 9357 here, it means like all the values are present. If some values is missing, this values will be lower. Let's say that the value here is 9347. That means like 10 values are missing and the remaining values are non-null values. This will also contains the data type. Okay, so what is the data type of each row? So date and time are in the form of object. So when the data that you have in the form of strings, so it will be considered as object, and the remaining values are in the form of floating points. So float 64. So you can see all the values are floating point values. Okay, so here this tells that there are no missing values. So there is also another way to check whether there are any missing values in your data set. For that there is another function. So this will be for checking the number of missing values in the data frame. So for this you have to mention the data frame name dot is null dot sum. Okay, so what this basically tells you is the number of missing values in each column. So you have date. So date is 0. That means like no values are missing in date. So time is 0. CO is 0. That means like 0 values are missing from each column. Okay, so what this tells you is like all the values are present, no values are missing. But here is the catch. If you refer this, there is a line here. So somewhere here. So I'll just check it. So yeah, so this one as well as both the sensor. So yeah, missing values are tagged with minus 200 value. So instead of, so what is missing values is like if the missing values is represented as this NaN, this SNL function will count the total number of NaN you have in this data set. But what this this UZA people who have built this data set has done is, instead of having these values as NaN, they have substituted the value as minus 200 in all the cases. So if you see here, all these values are minus 200 in this particular column in the last 5 rows. So what they have done is, instead of having this NaN, they have replaced all the values with minus 200 values. So what this means is, if there is minus 200 in your data frame, that means like those are missing values. So these are not actual values. So these are like null values. So we have to convert this back to NaN to count how many actual missing values are there. So this doesn't tell you the actual thing. Okay, so here I'll just represent what we have inferenced from here. So this shows that there are no missing values in the data set. Okay, so in the data set, but the actual missing values, so it is always a good practice to include this descriptions and comments about your code, so that if someone else is going through your code, they can understand it clearly. Okay, so but the actual missing values are tagged with the value minus 200. Okay, minus 200. So this is given in UCA repository. Okay, so you can refer this one. I'll also mention this. So this is described in UCA repository documentation or whatever. Okay, so documentation. Let us put this like this. Now let's count how many minus 200 values are there in the data frame. So this part will be counting. So this will actually tell you what are the real missing values in the data. Counting the number of times minus 200 appears in the data. Okay, so appears in the data. Okay, so the reason is like sometimes instead of having this NaN, the person who is curating the data would convert all the missing values to 0 or a large value like 999 or minus 200 minus 100 or something. So that's why we have the values like this. So this is just for basic data storage part. So instead of having the value as some string format, so you can see that all the values in this column are in the form of floating point. But if they have the values in this form of NaN, it's kind of there is a mix of data types, right? So that's why they used to convert these values into proper numbers, and they have also given us this representation that minus 200 means missing values. Now we are going to count how many minus 200 are there in our data set. So I'll copy this air quality data. So air quality data dot is in. So I'm going to check how many minus 200 values are there in my data set. For this, we will be using this isIn function. And within this parenthesis, you have to mention minus 200. So the number which you are checking. So if you are checking, how many times the number 80 is repeated, so you have to give 80 here. So here we are checking minus 200. So we have to represent minus 200 here. Dot sum. So this will give you the count of axis is equal to 0. So we are going to count how many rows has this minus 200 values in my data frame. So the basically the total number of values. Now let's run this. So this will tell you the number of minus 200 are there. So what this means is date doesn't contain any minus 200 values. So this basically tells you no values are missing from the date column and no values are missing from this again time column and so on. Whereas if you see the COGT column, 1683 values are missing, but this is not obvious in this YesNull thing because they have converted to minus 200. So when we check, this is the thing that we are getting, and most of the columns has 366 missing values. Okay. So now we cannot feed this data to our model, the FB profit model, because we have to process this missing values. And if we don't do that, it will kind of affect the performance of the model. Okay. So for this, there is one step of what we can do here. So here, this step is called as handling the missing values. Okay. Handling the missing values. So I'll just make this letters as bold. Like there are several steps on how you can handle the values. So you can replace the missing values with mean value or median value, or you can interpolate these values and so on. So there are several steps. So let's not go into the detail of it. Let's try to do the most simple one of how to handle the missing values. So in some other project videos, I'll try to include different methods of handling the missing values and so on. So here we are going to what we are basically going to do is we are going to convert all minus 200 into NaN, and after that we will be converting all the NaN to the mean of that particular column. So let's say if there is this COGT column here, right? So let's say that there are like 1000 missing values, and 1000 values are nothing but minus 200. So I will convert all this 1000 values into NaN, and after that I will calculate what is the mean of this CO column, and I will replace all the missing values with the mean column. For this, let's say this C6 sub 6 column, let's say there are 366 missing values. So I will find the mean of this particular column. So I won't include that minus 200. So that should not be included. Apart from this minus 200, we have to calculate the mean of this column and replace the missing value with mean. So this should be done for all the columns individually. Okay. So this is how you can handle the missing value. So this is one of the steps. Again, so this is not the only step we have. So we have multiple steps, but this is the most simplest one. Okay. So first step I'm going to do is I'm going to convert all minus 200 to NaN. So NaN means not a number. So Python and this data frame and NumPy recognizes this NaN as null values or missing values. So that's the reason. So this is a standard term, NaN is. Okay. So and once we have converted this, we will replace all NaN values with mean of that specific column. Okay. So this is very important. Specific column, because you cannot replace the missing values in this CO column with the mean of this column. Okay, so that's obvious, right? So if you want to replace the missing values in this column, you have to take the mean of this column alone. So that's the thing. So let's see how we can do this. So air quality data, quality data is equal to, again I'll just copy this and I'm going to convert this 200 to NaN, right? Dot replace. So replace is the function we are going to use, and we have to mention to replace. So what you are going to replace here? So I'm going to replace minus 200. Okay, and next attribute we have to mention is with what value you are going to replace. I'm going to replace this with np.n. Okay, so np.n. So here np is nothing but the numpy library that we have imported. So when you say np.nan, so it is telling that I want to replace all the values with nan values with this not a number or missing values. Okay, so that's the idea. So air quality data is equal to this data dot replace to replace. I want to replace this minus 200 with this np.nan. So I'll run this. And now I can run this one. So now all the minus 200 has been converted to null values. When I run this cell, it will give me the actual number of values. Previously it said all the values are 0, right? Now let's check. Now it is giving me the actual number of missing values that are present there. And now let's do is, let's try to convert this NaN values to the mean of each column. And I'll just put a text here as this shows the actual number of missing values. And let's try to print the last 5 columns. So previously, if you have seen this last 5 columns, you can see in this NHMC column, all the values are minus 200 in the last 5 rows. So when you run this, so all these values will be converted to NaN, so we can visualize that. So air quality data dot tail. So here we can see that those minus 200 has been converted to NaN. So this will be done throughout the data set, not only in these rows, but throughout the data set. And now I'll just mention the data frame name dot mean. Okay, so let's see what is the result we are getting. So when you say air quality data dot mean, this will give you what is the mean of each column. So the mean for COGT column is 2.1527. For this particular column is 1099.83 and so on. So all these things. So the reason we have converted this values to NaN is that if you haven't converted this minus 200 into NaN, these values will also be taken for calculating the mean. So that's why we are converting this NaN. So this 200 minus 200 into NaN. And after that we are calculating the mean. So now what we are going to do is we will take this mean value for COGT column, and in this column we will replace all the NaN values or the missing values with this value, and for PT we will replace this value and so on. So this is what we are going to do. It is a pretty simple step, so we don't have to do this for all the columns individually, so we don't have to do this manually, so we have functions for this. So air quality, so I'll just mention this as replacing the missing values with mean value. Okay, so mean value of each column. So air quality data is equal to dot fill in a of air quality dot mean. So air quality dot mean. Okay. Okay, so what we are doing here is, so fill NA means fill the missing values. NA means not available. So I'm going to fill all the missing values that are present in this air quality data with the mean of this particular data frame. So when you run this air quality dot mean, we have seen that it will give the mean of all the columns. So it will replace all the missing values in each column with the corresponding mean. And let's run this, and let's see this again. Okay, air quality data, and now I'll print this tail again. Let's see whether the NaN has been replaced. Yeah, so previously we have NaN in this NMHC column, right? So now we have 218. The 218 is the reason is, so this is the mean value for this NMHC column. So you can just go through it to understand what is that particular, NMHC is. Okay. So this is how you can replace the missing values with mean of each column. So like we have done most of the processing part. Okay. So once you have done this, if you check this number of missing values again, so this will tell us 0 because we have replaced all the missing values. So again, we are checking the missing values. So this is the majority of the data processing that we have to do. Now, there are two things that we can do with this data set. Okay, so I'll mention this here. So two machine learning applications are there for this particular data set. Two tasks can be performed on this data set, and those two tasks are, the first one is forecasting, and the second one is regression. Okay, so forecasting and regression. So what is meant by this forecasting is, so when we have a time series data, so time series data is the type of the data where, so you have this date and time, right? So all the data are kind of sequential. So we have the time, date and the timestamp for all these data points. So when you have this kind of data, we can use forecasting models which try to understand what is the trend previously, and based on this trend it will give you what is the future trend. So it is kind of forecasting what the values are going to be. So the main applications of this forecasting models is when we have time series data. Time series data is nothing but when you have date or time information. So the important applications for this is like stock price predictions and climatic change predictions, weather predictions, and so on, where there is some kind of trend can be repeated. Whereas regression can be performed on the data set where you don't have this timestamp data. So there is a data called as Boston house price data. I'll show you. So Boston house price data. So you can just go to Google and search this. Okay, so if you see this Kaggle data set that is present here, so I'll go to this data. So the values are not proper here. So sklearn.dataset load Boston. So sklearn has this particular data thing. So the different columns that you have here are let me check. So it is not also given properly. Boston house prediction. So house price data set. Yeah, so this is the data set. So these are all the columns that you have. Okay. So first column that you have is crime rate. So what is the per capita crime rate of that particular town, particularly in Boston? And you have this zone. So you can go through all these things. So RM means like the average number of rooms you have in this, the age of the person who is owning that house, and so on and so on. Okay. And this is the value that we are interested in predicting, which is the median value of owners occupied home. So what is the price of the home? So this is what we are going to do. So the idea of this data set is when you give all this value, the crime rate, zone, number of rooms, and all those things, the machine learning model should predict what is the price of the house. So this is what we call as a regression, where we are kind of trying to predict some number, some numerical value. So here there is no time related data, right? So we have this crime rate, zone, and so on, but we don't have this date or time related data. We call this as temporal data. When you have this time related data, that is when we have to do forecasting. So in this case, you also do regression where you can take this CO column as your output variable. So in this case, for this Boston house price data set, the output variable is this median value, right? Whereas in this case, you can take the COGTR output variable, and these things will be your input variable. So when you give all these values, your model will predict the COGT value, and that will be an example of regression. Okay. Whereas if you include this date and time information and you kind of try to predict what is the trend is going to be in the future, that is called as forecasting. So in this case, you can apply both of these things here, but whenever there is a time related data, we go with forecasting thing, because like this is a time series data which is also given here. So multivariate, which means like multiple variables are nothing but this different attributes that we have, and this is a time series data, so we can try this forecasting. So you can also go with regression, that's not an issue. You can just choose any one column, CO column or C6H5 column as one column, and you can check how this value is changing when all the other values are changing, and this is what we call as regression. So let's work on a regression problem later, but now let's try to focus on this forecasting. So how we can forecast this trend of a particular thing. So we have, let's say that we have this carbon monoxide. So the basic understanding of this forecasting is like I have the data. So if you see this yet, so data.yet. Okay, so I have the values from 10/3/2004 at this particular time all the way up to. So if I print the tail, yeah, so this is my this is the starting date and time. So 10/3/2004 to 18. So 18 times is like 6 p.m. until 04/4/2005. So from 2004 to 2005, 365, like 1 year of data with the hourly data is there. So this forecasting model will try to capture what is the trend in this data. Let's take only one column. Let's take the COGT column. So it will try to check how the CO values have been changing with this particular time information, and based on this it will give you what is the future trend is going to be. So that is what like forecasting is widely used. So this is also similar to the stock prices, right? So based on how the stocks has performed previously, let's say in the previous last 2 years or 3 years, we can predict what's the trend is going to be using this forecasting models. And we have different models. So for this you can use even LSTM. So LSTM stands for long short term memory, so it is a different kind of model. Whereas in this case we are going to use the FB profit model, which is again a forecasting model. So I'll just mention this as forecasting with FB profit model, or you can say as FB profit algorithm. So this is the model that we are going to use. I'll just make this bold. And so you can just go to this, you can just search for FB Profit documentation. It will take you here. Okay, so just copy this link and put it here as FB Profit documentation. So it will tell you how to use this particular model. Okay, so this will be the link. Okay, so you can just go to Google and search this how FB Profit works. So the idea is it kind of tries to capture the non-linear trends that are present here, and it can also capture the seasonality changes. So let's say that we are trying to predict what the weather would be. So weather or climate, if you consider, so it is kind of a repetitive thing, right? So let's say that in the month of March, it is like kind of very hot in India or something like that, and in the month of November and December, there is like, let's say there is like huge rain and so on. So this is kind of this kind of trends kind of repeats itself, right? So this is kind of a cycle. So whereas the other type is it doesn't follow a particular trend. Let's say, let's consider this pollution itself. So it's not like there is a possibility that the pollution also kind of increases at one particular month and decreases at one particular month. Whereas there is also but there is also another possibility that this pollution is kind of increasing each year, each month. So there is also another problem, because let's say that the automobile count are increasing, so the pollution has been increasing constantly. So these are like two kinds of trends that we can follow. So we can also say to this FB Profit that there is the seasonality repetition is there, or we can also say that there is no seasonality repetition for this one. So you have to fix this or decide this based on this particular logic. So you have to think whether this one is going to repeat. So if it is a climate, it is something that is going to repeat. Stock prices, it may not repeat, right? So we don't have to say it kind of repeats and so on. So we have to make that particular decision. So we will come back to that later when we are implementing this FB Profit. But let's try to understand what are all the basic things for implementing this FB Profit. So once you go to this documentation, so here they have given that it can take only two columns. One is the DS column and the another one is Y column. So it cannot take many more columns than that. So it can take only two columns. So one column should be the date and time information, and then you can take only one column. Let's say that we are taking the COGT column. Okay, so we will give this time data, date and time data DS, and we will give the COGT column. So we won't include any other columns. So this is only for finding what is the trend for COGT alone. So if you want to find this for PT08 column, so you can give this Y as this PT08 and so on. So you can take this columns individually, but this date and time should always be there. Okay, and there are like two formats. So you can see, so the two columns. So FB Profit is always a data frame with two columns. One is DS and Y, and DS is nothing but the date stamp column, and it should be in the format year. So it is like year, month, and date format, or it can also have year, month, date as well as the time. So in some cases you won't have the hourly data, you will have only the date informations. So in that case you can pass only the date. In case you have the hourly date itself, so we call that as timestamp. We have to combine this date and the time. Okay, and the format should be the same. So it should be like years hyphen month and again hyphen date. So hours, this colon, month, seconds, and so on. But the data set that we have here is contains date and time in two different columns, and we have this dot and slash and so on. So we have to convert this day, month, year. So we have seen. So this is in the form of day, month, and year. So we have to convert that to year, month, and date, and we have to combine this date information and the time information. So once we have done that, we can put that in this DS column, and we can take the Y column, and we can forecast this model using this model.fit function and so on. So this is the last processing that we have to do. Okay. So this step will be converting the date, converting the date. Okay, sorry, it's not data, it's date from uh, day, month, and year to, should be, you can say this FP Profit should be year, month, and date, right? So year, month, and date. So this is the conversion that we want to make. So again, we don't have to do this manually. So I'll create a variable called as the date info, and this date info is nothing but pd dot to date time, p dot date time of air quality data. So the data frame which we have, so air quality data You have to mention the column name. So quality date of date. Okay, so this date is nothing but the column name. Yeah, so this date. So what we are doing here is, so pandas as a function called as toDateType. When you have this date information, date kind of data type is there, you can convert this to this year, month, and day format. So I'm storing all those values to this variable called as date info. Okay, and after this, let's also try to print this. Sorry, this shouldn't be data info; it should be date info. So copy this and print this one. Now you can see here previously it is in the form of day, month, and year, and now we have converted this successfully to year, month, and a day. Okay, so yeah, so that has been done. So just a second. So where is my date? So 10/3. Okay, so this is the format, and now what I'm going to do here is we have to replace this time as well. So if you see this time. Okay, so where is my time information? So time, so instead of having the column, we have this dots, right? So we have to, uh, convert this dot to this particular column symbols and so on. So let's try to see how we can do that. So I'll name this as time info. Time info is equal to time again. So time info dot apply. So I'm going to use the lambda function. So lambda is what we call as single line function. So lambda, so this is again a keyword in Python, a key function that is present in Python. X is to x dot replace. I'm going to replace a dot to this column. Okay, so that it is in this particular format. So that's the idea. And yeah, so day, month, and okay. So I think that's it. And after that, we can also print this time info as well. Okay, so date time info is not defined. Sorry, so this should be okay. So first, what I'll do is I'll take this column alone and I'll store this in the date info. Sorry, the time info. So I'm creating a variable called as time info, and this time info is nothing but my air quality data. And when I use this within this square codes, what I'm doing here is I'm taking that particular column alone. Okay, so time info air quality data time, and yeah, so let's see. I'll print this one. So I'm going to print my time info. Okay, so now you can see it has dot, right? So we are going to convert this dot to this particular symbol. So let's run this one, and again let's print this time info, and let's see whether this change has been included in it. Okay, so as we see here, this dots has been converted to this symbol, and this is what the profit model expects as well. So it should be in the hour, minute, and second format, and we have converted this. Okay, so let's see whether we have to do any more changes to it. Okay, so now let's try to check what is the data type of this time info and date info. So I'll print type of date info. So we know that date info is nothing but the converted format of this date, and I'll just copy this and put this as, sorry, as time info as well. Time of info, let's see. So this is in the form of pandas a series, right? So let's try to understand what is meant by this series. So pandas basically has two data types. One is like objects, or we can call this as objects. One is data frame, and the another one is series. So data frame is nothing but it is like a table that contains several rows and several columns, whereas series is something that contains only one row or one column. So it is not like multi-dimensional. So it just contains this one row or one column. So that is what the series is. Now what I'm going to do here is I'm going to create a data frame where the first column will be my date and the second column will be my time. So let's do that. And so for this we can use the concat function that we have in pandas. Okay, so I'll just create a text as combining two series. So like one series is the date info and the other series is the time info. So combining two series to a pandas data frame And let's name this data frame as date info, or sorry, so let's name this as date time because we are combining that, right? So date time is equal to pd.concat. So within this parenthesis, just create a list with the square bracket. So first element in this list should be the date info, and the second parameter should be my time info. Okay, and access should be equal to 1. So access is equal to 1. So we are combining two columns here, right? So date is one column and the time is another column. So we are using access is equal to 1. If you are combining rows, in that case, you will be using access is equal to 0. So let's run this one. So now this will create a data frame called as date time, and copy this and print the first 5 rows of this data frame. So data time dot end. Okay, there are like date and time information alone. Again, you can also check what is the shape of this data frame. So dot shape. So 9357. So we know that. So we now it contains only two columns, which is date and time. There is one more thing that we have to do. So it should not be present in two columns. The date information and the time information should be combined together, and it should be present in a column named as DS. So the next step will be combining these two columns. So previously we have created a data frame with these two columns, and now I'm going to convert these two columns into one single column. Okay. So I'll just comment this as combining date and time. So how we can do this is date time ds. So I'm creating a new column in this date time data frame as a ds, and after that I'm going to mention a date time of date dot as type. I'm going to convert this to strings. I'll tell you why we are doing this. And now I have to combine it with a space plus again the date time of time, and this should also be converted to string. So we are basically combining these date and time, right? So we cannot. So this date is in the form of a date format. So we have to convert it to string format. After that, only we can join these two things. So this is just like joining two statements, and that's why we are converting it to string, and we are like combining it with a space between them. So which is what represented here. So there should be date and there should be a space, and then we should have the time information, and that's what we are doing here. So we are creating a new column called as ds, and this column is nothing but I'm taking the date column, which is this one, and I'm adding a space and I'm combining the time with it, and I'm just converting them to string columns, and later we will combine, convert this back to the date time. But let's try to understand this first. Date time ds is not defined. Okay. Okay, sorry. So again, so it should not be data, so it should be date time. Okay, yeah. Okay, so now let's try to print this yet first. This will tell us that the yet will contain like 3 columns. Yeah, so this value is nothing but the combination of this this value is nothing but the combination of this date information and time information. Okay, so this will be the first column that we will give to this FB profit model, which is this ds, and before that we just have to convert this back to date format. Okay, so if I just copy this date time dot info, we know that it will print the number of normal values and the data type. Okay, so this date in the form of date time thing, right? Whereas the other two things are in the form of object is nothing but string, because we have converted them to string, so we have to convert them back to the date time format. So I just mentioned here as we have to convert ds from object data type to date time format. Okay, format or data types, everything is the same one. And now I'm going to create a new data frame. So let's name this data frame as data, and in order to convert this you can mention pd dot data frame. So D and F should be caps, and mention the parenthesis. So this will create a empty data frame. And this empty, why I'm creating this is the input, input data for my FB profit. As you can see, so the input to profit is always a data frame with 2 columns, DS and Y. This column, the previous column, has date and time extra columns, right? So we have to create a new column which has only this DS and Y. So we will choose this Y from any of the columns that we have. So we have these many columns, so we can choose one Y from that. But let's try to create this DS first. So I'm calling this data, the new data frame that I created, and I'm going to create a column as ds. Okay, so you should not create columns with any other name, because Prophet can understand only ds. So ds is equal to pd dot date time, p dot date time of this date time ds. So date time ds. Okay, so what I'm doing here is, so I'm creating a new column called as ds, and this column is nothing but I'm taking the ds column from this previous data set and I'm converting back to pd dot date time format. Okay, so I'll run this, and now you can print the head of this data, convert class, and cannot convert the series to it. Okay, so there is some issue over here. So date time of ds, data ds d dot date time. Okay, so string as type, string as type. Okay, so let me just do this again. Why this is giving me an error? So data of ds is equal to pd dot date time of ds. Okay. Okay, so the thing is, it shouldn't be pd dot datetime, so it should be pd dot to datetime. So that is the problem. So I'll run this one again. Now you can just a second. Okay, so now I'll go to this data dot date. Okay, yeah, now you can see, so I have ds now, and this now is in the form of this date and the timestamp information, and now I just have to include a y. Okay, so you have about like 13 or 14 columns, right? So in this you can choose one variable, and you can check the trend of that particular variable. Okay, so in this so you have this co, pt, and so on. So I'll take this maybe this RH. Okay, so RH is nothing but the relative humidity percentage, right? So yeah, so relative humidity. So what is the relative humidity percentage? So you can also take other values as well. So it is up to you. So I'll take this RH1. So I'm going to take this RH from the original air quality data. Okay. So now, so as I've created a new column as a DS, similarly, I'm going to create a new column as a Y, because that's what a Prophet, FB Prophet understand, is equal to air quality data, which is my original data frame, and the column that I'm going to convert is this y, right? Sorry, it's not y, it's RH. So RH stands for relative humidity. So you can see, so it's RH. So data of y is equal to air quality data RH, and now you can print this data dot eight, dot eight. Okay. Yeah, so now this data frame has two columns. First column is DS, second column is Y. So this is similar to what a Prophet kind of expects. So it kind of expects a date information and the Y, and that's what we have given. So Y here is nothing but the relative humidity. And when you fit this to your FB Prophet model, and you kind of predicted, it will give you what is the future trend of that particular relative humidity. And for this, first we have to import this Prophet. So this Prophet may not be present in Collab itself. So I'll try to import this. So for importing, you have to mention from Prophet uh, import, P should be caps, from Prophet import. Let's see whether the Prophet library is installed. Okay, so there is no module name Prophet, so we have to run this pip install command. So it's pip install Prophet. So after that we can import it. Okay, so let's wait for the library to get installed. So it won't take that much time. So it's this Prophet library is getting installed here. So this Prophet is the model that we are going to use. And once this has been done, so we can just fit the data, fit this ds and y. After that we can calculate this relative humidity value. So yeah, this is taking some time. I'll also run this one as well. So once this is completed, the model will be imported, and you can go through here to understand how we can use this. So first you have to import the Prophet model, and once you have the data in this format, you have to create this. You can use m is equal to Prophet or model is equal to Prophet. Everything is same, and model dot fit of df. So df is nothing but the data frame that you have. Okay. So after that, so once you have fitted the model, and you can do this make future prediction. So what is the period? So the number of days that you want to predict. Here we will use this periods as 360 and frequency as h. Frequency h is nothing but hourly data because we are working with hourly data, right? So that's the thing. And after that you have this y at lower, and so what is the upper value predicted, lower value predicted, and so on, and you can plot graph like this. So this is the previous trend observed, and then you will get what is the future trend that is expected, and you can also draw the trend lines like this. So we will try to do all these things here once this profit has been installed. So it is taking a bit longer, so let's try to do the remaining part of the code also. So okay, so errors dependency result. Okay, so this is not a problem. As you can see here, now the profit model has been installed here and it has been imported. Okay, now we can use this one, and this part will be training. I'll name this as training the profit model, which is my forecasting model. So I'm going to create a variable called as model, and I'm going to load my profit to it. So profit of, so you have to mention this parenthesis, and model dot fit. So what I'm going to fit is the data frame that I've created. So the data frame name is data. So in this case, they have named the data frame as df, right? So it is not a problem. So instead of like fit of df, so we have to mention the data frame name, which is like data. Okay. So model dot fit of data, which contains two columns, which is ds and y. Okay. So let's wait for it to get trained. And once it is trained, we can make the future prediction. So you can see disabling yearly seasonality, run profit with yearly seasonality is equal to 2 to override this. So what this basically tells you is, as I've told you, few things there will be like seasonality will be there, some repetition, or it is kind of a cycle. So for that things, you can just mention this yearly seasonality is equal to true within this profit of year. Okay, so when you mention this, the seasonality will be taken into consideration, but at default, this particular yearly seasonality will be false. So I'll remove this. If you want, you can check this one as well. So first frame this predicted, and you can also check later on what the result is when you implement this yearly seasonality is equal to true. So this has been, so my profit model has been trained, and so we will be using the same code that we have. So this is for Python, and if you are working on R, they also have the code for the R program as well. So let's focus on Python part. So this is for making future prediction, which is equal to future of m dot make future data frame, right? So I'll just copy this and put it here. So this is for making future prediction. So instead of m, we have this model, right? So I'll replace this to model, and yeah, future dot n. So this will give us the last five predictions that we are making. Periods is equal to 365, and we have to mention the frequency as frequency is equal to h. So here they are just working on date information, right? So they don't have the timestamp information, but we have hourly data. So we are mentioning this frequency as such. So it will give the forecast for hourly data itself. So tail, and I'll run this. So what this is like, this is the data, or like the date and time information for which the profit is kind of calculating the what should I say? So it kind of calculates the y value, which is my relative humidity. So if you see here, this is in the form of, so we know that this is year, this is month, and this is in the form of day. Whereas if you see this previously, we had the date information in the form of year, day, and month. Okay, so what I'm trying to see here is, if we go to this yet thing, so 10/03/2004. So 10 is my day, 3 is my month, which is March 2004. But when we are converted to this date time, so here you can see it is in the form of year, day, and month. Okay, so it is not in the form of year, month, and day as we needed, but in the form of year, day, and month. But it is not a problem because this is a preferred way of doing this. Okay, so year, month, and day is a preferred way of doing that, but profit kind of understand this as well. So it is not an issue. So if we are worrying about that, so it kind of works well only because here you can see that the data has been transformed here. So we know that there is no month as 19, right? So this is actually the date information, and this is my month. So the profit kind of understand that, okay, so here the data is not in the form of year, month, and day, it is in the form of year, day, and month. So here day and month, so it kind of transform it, and it will give you in this format, year, month, and day, which is the default format in profit. Okay, so this is the thing, and now we can use this forecast. So I'm creating a variable called as forecast is equal to model dot predict. So this is just nothing but the periods for which we are going to predict. So for future, and this is where we are going to predict the y value. Y value is nothing but the relative humidity. So this will also be given in this documentation itself. So once we have this periods, you will predict the future. So this is my y at. Okay. So model dot predict. So just copy this one. You can copy and paste it here. Uh, Forecast of, so m should be replaced with model. So we know that. So model dot forecast. So ds is the initial date and time information. Y at is kind of the middle value. Y at lower is the, so we are just giving some tolerance as lower value and upper value. Y at is the predicted value. So that is what it is, and we are predicting the value for this last 5 rows. So let's run this. Okay, so this will predict the value for these things. So let's wait for some time to give the values. Okay, so this is my y at predicted value, and I have a lower kind of tolerance and upper kind of tolerance. This is kind of the middle thing or the actual predictions. We are just giving some tolerance value to it. So this is the value predicted by our model. So we are giving the value or giving the data until this part. So if you go to this data.tail, so we have until this 2005, this month, fourth month, and this particular time, right? And now we have made predictions for let's check 2005, 12th December month, 19th, and this is the time. So previously it was until this fourth month, April, right? So this is how you can make a future prediction. This is the y value or the relative humidity for this particular thing. So this is how capture the trend, and you can predict the values. And similarly, once you have these values, you can also make plots like this. So I just copy this and paste it here. So all the things are kind of the same. So if you want to predict this for temperature, so let's say that you want to do this for this absolute humidity instead of this relative humidity. So you just have to do one change. So here instead of RH, you have to mention uh, this AH. So if you want to predict this for CO level, so you have to replace this RH with CO and so on. So this is, but you have to do this individually. So that's the only thing that you have to remember. So I'll convert this M to model, and this will give me plot of what is the forecasters. So let's wait for this plot. Okay, so we have this line, right? So this line is nothing but the values that we have here, y at, and then I have this upper limit and lower limit. So this is the trend. So it kind of this is the data that we had previously. Okay, so the training data that we gave until like 2005 April month. So it kind of decreases first, increases, and it kind of the same. And based on those trends, it will try to capture what the trend can be in the future, and this line represents what the trend is going to be. And you can also make trends like this. Okay, so I'll copy this, and it will give you trends in weekly, yearly, and day information as well. So let's paste it here, and m dot model. So there is like so much information that you can get from this particular plot. Okay, so you can see, so like it's hard for us to understand how the model does this, but it is purely based on the data set that we have. So this is for trend in monthly cases. So you have 2004 one, so January month, and then April, July, and so on. So the monthly information until like 2006 one, so January of 2001 is there. So this is the last thing, which is around 2005 December, which is the last data point that we have. And time of 4 a.m. So this is the thing. You can also increase the periods in order to get the train for several more days, and this is weekly. So from the weekday, so it's kind of the relative humidity kind of like increasing, like it's kind of more during like Sunday and Monday. It kind of decreases in Tuesday and increases to Wednesday, Sunday, and so on, and kind of this kind of follows. So this is what the model tells. So like for the start of month, from Sunday to Monday, the relative humidity is high, and it is decreasing, and it kind of like increasing. So all these are captured from the data that we have provided. And this is like what is the relative humidity in the hours of the day. So this is like the like 12 a.m. and all the way up to the 12 a.m. of the next day. So this is how the relative humidity changes. Now what you can do is, instead of this relative humidity, you can also try to capture the trend for different air quality predictions and so on. So that's it for this video. I hope that you have understood all the things that we have covered here. I'll just give you a quick recap of what are all the things that we have done here. So we have seen that so first thing is just importing the NumPy and Pandas library, and I've explained you the data set that we have, which is the air quality data in this UCML repository. The important key information that you have to understand are like this many rows are there, this many columns are there, and all the missing values are tagged with -200. So like we have seen that the values are not separated by comma but by semicolon. So we have used this separation is equal to semicolon, and the decimal values are separated by comma instead of decimal points, and we are converting that using this decimal. And then we are removing the last two columns because they are just some unwanted columns which contains only missing values. And later, so this is just to print the last five columns, and we have seen that there are some empty rows are there, so we are removing those. We're taking only the 9357 rows that are present in the data set. And later we are checking for missing values, so we are checking how many times -200 has been repeated. Later we are converting this 200 back to NaN values, and then we are finding the mean of each column and replacing the missing value with this mean column and so on. So the later what we are doing is like this part is working with the FP profit model, where we the important task here is to use our data, convert the date and time information we have in order to into something where the FB profit model can understand to this date and time information. So that's what we are doing here. So previously we had this day, month, and year, and now we have year, month, and date, and so on. And then we are replacing this dot with colon and so on. And then we are combining these two columns. Later, we are combining these two columns into one single column called as DS, and we are converting them from string to date time format as well using this two date time function. So later, so we are just including this y. So here y we are taking as relative humidity. So we are trying to find how the relative humidity kind of changes each month, and how it changes weekly, and how it changes hourly. So that is what we are going to predict. So I'm installing the profit library, importing the profit model, fitting it with the data that I have, and this will I'm setting how many periods that I wanted to calculate this value. So this will give me the lower value, upper value, and the predicted value. So this is the plot, and we can get more information using this plot components. For this plot, you have to use model.plot forecast. Forecast is nothing but the predicted value, and for this one, you have to use plot component. So you have the trend monthly wise, and this is the RH value, relative humidity value is present in the y-axis. So here as well. So y is my relative humidity value, y-axis, and in the x-axis you have the time information. And this is for a weekly. So how the relative humidity changes like each day of the week, and how it changes each hour of the week. So everything is captured from the data that we have given. So I hope everyone is clear until this part. So you can practice all this codes in order to understand this clearly. So that's it from my side, and I'll see you in the next upload. Thanks for watching.